we've been showing last year what we did with Intel around Telco IT Cloud energy monitoring. We've been expanding our capability thanks to the collaboration with Intel. And today I will show you what we've been doing in terms of extension, how we extended our solution to VMware Farm Data Center. But before that, let me remind of what our solution enable our customers to do. The first one is really with our combined solution, we bring visibility. By combining Intel Power Management telemetry stack with our experience in service assurance and EA service assurance end-to-end, we bring visibility, we link the energy consumption from the IT Telco Cloud to the application workload performance management. So we are able to identify how this IT Telco Cloud energy consumption is distributed across the various hosts. The second thing is we are able to benchmark and profile the workload application, power consumption, carbon footprint, and link this again with the workload application performance. The third thing is whenever it's possible, thanks to our automation framework combined with Intel Power Management telemetry stack, we are able to run a closed loop scenario that can optimize the power energy consumption on a particular host or CPU. Let me show you how this works. We are bringing visibility about the power consumption of MYCOM OSI data center across the various countries. And as you can see, we have two types of IT data center. The data center was via the VMware Farm and the IT Cloud. What we can observe is the total power consumption over a week. How much does it cost related to the country? Of course, from country to country, this varies. What is the total carbon footprint per week? And what is the overall utilization of the data center? So this is the first dashboard that bring visibility about how this energy is consumed. Of course, we would like to know more. And to know more, we will be able to, let's, for example, focus on the data center. As we mentioned, we have two data centers, one in France, one in India. So here again, we can see in this particular dashboard, how many hosts do we have? What's the average host CPU utilization? What is the total power consumption across the host? How many VMs we have on the cost? What is the average CPU load per VM? And finally, how much effectively all these workloads, VMs, are consuming in terms of power. We can see the trends over the per day of the power consumption and how much this is costing. We can see the distribution. How is this distributed between the various data centers? So again, bringing visibility on how the power is consumed across those data centers. Now let me show you how we correlate this to the application. So this dashboard illustrates the power consumption of our EA suite and carbon footprint. First, we collect part of our data collection. We collect the configuration of the system, which VM, how many VMs, what's the amount of memory allocated, CPUs, and so on. All this links to the application. So this is EA suite. And based on that, we are able to link the total amount of power per day, per week, the total amount of cost based on the location, the carbon footprint we generate per week, and the evolution. So as I mentioned, we are linking the energy consumption to application. We are starting by applying it to our own application. The third measure that I mentioned is about automation. And this is an example of how on a data center, extra large data center, the saving that we can potentially achieve through our combined automation, closed loop automation with Intel, to where we can act at host level or core or CPU level by changing the states or the frequency of the CPU. And we've been measuring in various trials about 40% saving. This can go up to nearly 60% of saving. So tremendous opportunity there in terms of power energy saving.